if there's a strong antenna that can pick up this power signal, we're trying to figure out how much power it would receive. And, well, we have this type of situation, P source divided by the area. That's usually called intensity. And so we can calculate that as being 87 picowatts divided by 4.9, 16 meters squared. We should get 0.87. This is negative 12, and 4.9, 16. Therefore, the intensity is 1.78 to the negative 29 watts over meter squared. For the power received by this antenna radius, so we need to use, basically we need to figure out what the area is, because notice how this is watts over meters squared, but they're asking for power. Now power is just watts. So how do you get watts from that? You have to multiply this by some sort of meters squared. That would probably be this radius. So I'm sure that if this is a circular antenna, then the area would be pi r squared. So let's use that to try to figure out the power received. Well, let's multiply that by pi times 195 squared. And so we get that the power received is going to be 2.12 e to the negative 24 watts. So now we're trying to find what kind of power source will be able to provide this kind of intensity. And in order to do that, we'll have to say 1.78 negative 29 watts over meters squared. Let's set up the new ratio. This time we're looking for a power source at what kind of area? Well, remember it's 4 pi d squared. This d comes from this 31,000 times the light years. So we got 9.46 by 15. So the distance is 2.9 to the 20 meters. And now we can use this equation. So let's go ahead and just square that, multiply that by pi, and then times 4, and then times this stuff, 1.78 negative 29. So that way we get the power source as that far away is going to be 1.9 e to the 13 watts.